The next topic is about the exponents or power and radicals. All right. But first, let's talk about the exponents or the power term. Here, when you see the term of x to the power n, when you say about this expression, you can say that x raised to the power n. But for short, you just say that x to the power n. Alright, so what does it mean by that? X to the power n means that you're going to have the n terms of x. For example, here where you have the term of 2 to the power 3. So here it means that you have 3 terms of 2. So now you have 1 term, 2 terms, and then 3 terms of 3. I'm sorry. Yeah, you have 3 terms of 2. Alright, and then if you multiply out this expression, you're gonna get 8. Alright, or if you have the term 3 square, so it means that you have 2 terms of 3. You have 1 term and then 2 terms. So the result will give you 9. Alright, everyone know that 3 square is equal to 9. Okay, so here you can say that the term of exponent or the power is going to tell you the number of repeating term. Alright, for example, if you have 2 to the power 3, right? Now you're going to have 1, 2, 3 terms of 2. You have 3 repeating terms of 2. So again, for this power of 2, alright? So now you have 1, 2 terms, repeating terms of the number 3. Okay. So in general, if you have x to the power n, alright, so it means that you're going to have n terms of x. So here, x will be repeating. I'm sorry, x will be repeated n times. Okay. And then you're going to multiply all of them together. But how about if the power is negative number, or when the exponent is negative number? So it's going to be this case. All right, now you can have x to the power minus n. Okay, whenever you see the negative power or the negative exponent, all right, you have to know that this will give you the reciprocal. All right, you just flip upside down the term of x to the power n. So you're gonna get 1 to the power x to the power n, right? It is 1 over x to the power n. And then for x to the power n, you're going to have 1, 2, 3, on and on until n terms of x. All right. In this case, x cannot be 0. All right. Otherwise, the bottom term right here is going to be 0. And then you're going to have 1 over 0, which is undefined. Okay, so in this case, x cannot be 0. I can give you some example. All right, where you have 2 to the power minus 3 or negative 3. Here, you just flip upside down to get the reciprocal. You take it to be 1 over 2 to the power 3. Okay, so in this case, you're gonna get 1 over 2 times 2 times 2. You have 3 repeating terms of 2. So you're gonna get 1 over 8 to be the result. Okay. On here, you can also get this rule. Okay, from this one, when you can see that these two exponents, they are in the opposite side, right? This one has the minus sign, this one don't have the minus sign, so the sign must be plus. All right, so you can use this thing to write down this term as well. When you have 1 over 2 to the power minus 3, all right, here if you want to get 2 to some power, all right, in this case you just, this power must have the opposite side, 2 minus 3, all right, so that's why you're going to get 2 to the power 3. All right, so again, this power and this power needs to have need to have the opposite sign. Okay, so you can get the next rule. Okay, now when you have the reciprocal term like this, all right, 1 over x to the power minus n. Okay, when you change it to be x to some power, all right, this power and this power needs to be in the opposite sign. Okay, so I can give you one more example. How about if we have like a 1 over 3 to the power minus 4. All right, here when you don't want to make it to be this reciprocal or in the form of flipping upside down. Okay, here you can change it to be 3 to the power 4. So again, this power and this power, they need to have the opposite sign. All right, one term has the minus power, or one term has the negative power, so another term needs to have the positive power. Okay, on here you can think about it in this way. How about if I put it in this way? Okay, here you can take it to be 3 with the opposite sign. All right, the opposite sign of minus 4. All right, so now you have minus and minus, you need to get plus. All right, so that's why we need to get 3 to the power 4. All right, so again, this power, all right, and this power needs to be in the opposite side. And to be the opposite, you need to put minus sign in front of this power, which is minus 4. All right, the next rule is whenever you have x to the power 0, it will give you 1. All right, in this case, x cannot be equal to 0. So for some example, if you have 5 to the power 0, okay, you can put it right away that this one must be equal to 1. All right, this term needs to be equal to 1. All right, the reason behind this one could be like this. All right, how about if you have 3 terms of 5, something like that. Okay, so here you can put it to be 5 to the power 3, right? And again, for the term at the bottom, how about if you also have 3 terms of 5 again? Okay, so here when you cancel everything, all right? This term will give you 1. Okay, let me put the term at the bottom. All right, the term at the bottom, it's going to be the same thing as the term on the top, right? So this will be 5 to the power 3 again. And we know that the result needs to give you 1. Okay, and here, when you have 5 to the power 3 divided by 5 to the power 3, okay, in this case, you can take it to be 5 to the power 3 and then minus 3. And this give you 5 to the power 0. Alright, so that's why 5 to the power 0 will give you 1. Okay, actually, to combine this power, we need to know some other rules. Alright, and I will talk about those rules later in the next slide. Alright, or I can give you one more example. How about if you have 3.14 to the power 0? So keep in mind that whenever this power is 0 or whenever this exponent is 0, alright, the result will give you 1 right away. Except for this case, if you have 0 to the power 0, alright, this term is undefined. You cannot find the value of this term. Okay, let's move to the next slide. We're gonna learn some more rules for the exponent. Here, in this case, all right, you have two terms multiplied together. Multiplying together. Right, this is the first term, x to the power m multiplied with x to the power n. Okay. Here, for the term of x to the power n, we can say that the term of x will be the term of base. And then for the term of n, it is the term of the exponent or power. Okay, so for the first rule right here, it is the case when you have the same base for both terms. All right, you have the base of x and x. In this case, you just combine the power together. All right, so the result will give you x to the power m plus n. So let me show you some example. All right, if you have 2 to the power 3 multiplied with 2 to the power 4. All right, for the first term, this power is 3, so it means that you have 3 repeating terms of 2. All right, so we can write out the terms. You have 3 terms of 2. And then for the next term, now this power is 4, so it means that you have 4 repeating terms of 2. Okay, so here you have 1, 2, 3, 4 terms. Okay, so here, if you count the total number of the number 2, how many do we have? You have 1, 2, 3, 4, 5, 6, and then 7. All right, so now we have 7 repeating terms of 2. So that's why we put it to be 2 to the power 7. All right, so how can we get the power of 7? All right, so it seems like we just add up 3 and 4 together. All right, 3 plus 4, you can get 7. So in this case, it's going to be 2 to the power of 3 plus 4. That's why you get 2 to the power 7. All right, so again, whenever you have the same base, all right, in this case, you just add up the power together. Okay, the next rule, so again, if the power is equal to 0, This give you 1, but x cannot be equal to 0, right? From the previous, I already gave you this example. 5 to the power 0, you get 1. Or some new example, 10 to the power 0, you still get 1. But keep in mind that if you have 0 to the power 0, this term will be undefined. About for the next rule, here, it is a case when you have the negative power, all right? In this case, you need to get the reciprocal, all right? Make it to be flipping upside down like this. But again, x cannot be equal to 0. Okay. For example, if you have 12 to the power minus 1, this will give you 1 over 12 to the power 1, which is 1 over 12. Or if you have 9 to the power minus 3, okay, this term will give you 1 over 9 to the power 3. The next rule, all right, it is similar to the rule number 3. All right, keep in mind that you need to get the opposite power. All right, you need to get the power in the opposite sides. So actually, we can have this example. If you have 1 over 3 to the power minus 2, this will give you 3 square. Right? This power needs to be in the opposite sides. The next rule here. This rule will be very similar to the rule number 1. Right? For the rule number 1, it is the case of multiplying. But for the rule number 5, it is the case of dividing. Okay, so again, if you have x to the power m, so this term will have the base of x, all right, and then it is divided by x to the power n. So again, this term also have the base of x again, all right. If this thing happens when you have the same base, now you can just take the subtraction between the power, all right. So this will give you x to the power m minus n. Or this term, all right, if you want to flip that term upside down to be 1 over x to some power, all right, here you need to put it to be in the opposite side. All right, so it will be minus of m minus n. So that's why you get 1 over x minus m plus n. And this will be the same thing as the term that is written here. All right, 1 over x to the power n minus m. Right? This term and this term, they are just the same. So let's see some example. How about if we have 2 to the power 5 divided by 2 square. All right, 2 to the power 5, it means that you have 5 repeating terms of 2. So let's write out all the terms. You have 1, 2, 3, 4, 5 terms. Then for 2 square, it means that you have 2 repeating terms of 2. You have only 2 terms. All right, and here you can do some cancellation like this. All right, so what is left will be just 3 repeating terms of 2. All right, you have 1, 2, 3 terms. So here we can put it to be 2 to the power 3. All right, And if I do this problem again, okay, let me put it up here. All right, in this case, in order to get the power of 3, you just take the subtraction between the two power. All right, it's going to be the power of 5 minus 2. That's why you get 2 to the power 3. So okay, in the case when you have the same base for the top and bottom term, now you just take subtraction between these two power to get the power of m minus n. All right. And then we also have some more rules. Here, you have the same base for both terms, all right, x and x. So in this case, you just take subtraction between the two powers. All right, so this thing will give you x to the power m minus m. M minus m, you get just 0. All right, so that's why we get just 1. So here, when the both terms have the same power and the same base, all right, the result will give you just 1. And then for some example, how about if I give you this one? You have 43 to the power 5 divided by the same thing. All right, this will give you 1 right away. Or you can do just the cancellation like this. All right. And then the next rule. In this case, you have only one base. All right, the base of x. This is the term of base. But here you take the power twice. All right, you take the power 2 times. The first time you take the power of m. All right, this is the first power. And then later on, you take the power of n to the whole term again. All right, so this is the case when you take the power twice. Okay, so if this thing happens, you just multiply the power together. So let's see some example. All right, how about if you have 2 square and then you take the power 3 outside again. Okay. First, if you look at this power, all right, it means that you have 3 repeating terms. But what will be the repeating term? All right. And this will be the repeating term. All right. So it means that you have 3 terms of 2 square. You have 1 term, 2 terms, and then 3 terms of 2 square. Okay, and 2 square, you're going to get 2 times 2, right? The next term again, 2 square, you still have 2 times 2. The last term as well, you also have 2 times 2. All right, so let's make out on the total number of 2. You have 1, 2, 3, 4, 5, 6 terms. Okay, so in this case, you need to get 2 to the power 6. And then you can see that in order to get the power of 6 right here, all right, you just multiply 2 and 3 together, right? You just multiply out these two power. 2 times 3, you get 6. Okay, so that's why in general, when you take the power twice, you just multiply the power together. Okay, here don't be confused with the rule number 1. In the rule number 1, you have 2 terms, but with the same base. All right. In that case, you just add up the power together. Okay, usually people are confused between these two rules. Okay, so when you use the rule, use it very carefully. And then let's move to the next rule. If you have x times y, and then you take the power n to the whole term. Okay, in this case, you just give this power to everything inside this parentheses. So the result will give you x to the power n multiplied with y to the power n. So let's see some example. Here, if I have the term like a 5 times 2, and then you put the power of 3. Okay, in this case, you can give this power to every term. So this will be 5 to the power 3 multiplied with 2 to the power 3. Alright, the next rule is very similar, but it is the case of the division or dividing. Right? So again, you can give this power to every term inside this parentheses. So the result will give you x to the power n divided by y to the power n. If you have 2 over 5, and then you put the power 3, right, so this will give you 2 to the power 3 over 5 to the power 3. Right, you can give this power to every term inside this parentheses. Okay. The next rule is very similar to the rule number 9. Alright. You can give the power of n to every term inside these parentheses. Alright. But here you also have the term of minus 1. Alright. Whenever you have the power of minus 1, it means that you need to get the reciprocal. You need to do the flipping upside down. Alright. So here, if you start from x divided by y, okay, you need to get the reciprocal, so the term will be flipped upside down. You're gonna get y divided by x. Okay. So here, if you have this example, 2 over 3, and then you put the power minus 4. Okay. Here, you can get the power 4. Okay. But for the term inside right here, you need to flip upside down of this number, 2 over 3. So actually, you're going to get 3 over 2. So that will be the answer. All right. So now let's do some more example. Here, how about if the term of the base is not a number? It could be the term of variable x, a, b, c, all right, x, y, z, a, b, c, on and on. All right, in this case, you just apply the same rule as before. Okay, for example, for the first problem right here, this is the case when you have the same base. All right, so in this case, just add up the power together. You're going to get x to the power 14. Okay, or in the next example, here you have the same base of a for the term number 1 and the term number 3. All right, so in this case, you just add up the power together. The power will be 3 plus 5. Okay, and you also have the same base of b. Okay, for the term of b itself, you can put it to be b to the power 1. All right, so in this case, just add up the power of 2 and 1. So actually, you're going to get a to the power 8 multiplied with b to the power 3. All right, this is how to simplify the term. You try to combine the like term together. In the next example, again, you have the same base of x. All right, so in this case, you just add up the power together. So this will give you x to the power 11 minus 5. You're going to get just x to the power 6. Or in the next example, here again, you have the same base of z or z, right? So just add up the power together. Two o five plus 305. All right. So now you just add up 2 and 3, right? Because for both fractions term, they have the same divisor, or they have the same denominator. So in this case, you get just z to the power 5 over 5. So you get just c to the power 1, or just c itself. Okay. The next problem is similar again, right? You have the same base of x. For the first term, you can take it to be x to the power 1. So in this case, you just add up the power together. Right here, you have 1 plus 0.5, you get 1.5, and it is equal to 3 over 2. So this will be the new power, the new exponent. All right, so let's move to the next slide. So let's try to evaluate. Okay, for this wording, you can see the word of value. So to evaluate, it means that you need to find the value. So let's do the first problem, the problem number 6. Okay, here, this you have the power 4. All right, so it means that you have 4 repeating terms of 2. So now you have 1, 2, 3, and then 4 terms of 2, right? And then if you multiply 2 and 2, you get 4. 2 and 2, you get 4 again. And then later on, you multiply 4 and 4, you get 16. So that's the result. Okay. And then for the next problem, now you see the negative power of minus 5. All right. Whenever you see the negative power, you need to get the reciprocal or make it to be flipping upside down. So actually, you're going to get 1 over 4 to the power 5. All right. And then at this step, okay, now you get the power of 5. All right. So it means that you have 5 repeating terms of 4. So you just write them out. You have 1, 2, 3, 4, 5 terms of 4. Okay. And then if you multiply 4 and 4, you get 16. 4 and 4, you get 16 again. All right, and then if you multiply 16 and 16, now you get how much? 256. All right, and then for the last step, now you multiply 4 and 256, you get 1024. All right, and then for the next problem, you can see that you take this term, all right, and then take the power 4 to the term. Okay, so in this case, you can give the power 4 to each term inside this parentheses. Alright, here you can apply the rule number, let me see, the rule number 7 right here. Okay, when you take the power twice, I'm sorry, it's not that one. It's gonna be the rule number 8. Okay, you have the power of n outside. Now you give this power to each term inside this parentheses. Okay, so this will be 2 to the power 7, and then you take the power 4 again. All right, the next term will become 3 to the power minus 2, and then you put the power 4 again. All right, and then for each term, it will be the case when you take the power twice. All right, so in this case, just multiply the power together here and here. All right, 7 times 4 you get 28. Minus 2 times 4 you get minus 8. Sorry, it's going to be multiply. Okay, and then for the second term, now you see the negative power. All right, you can make it to be reciprocal. You need to flip it upside down. All right, and then when you flip the term upside down, the new power will be in the opposite side to the original power. All right. The next one, here again, you just give this power to every term, or to everything inside the parentheses. So this will become 5 squared over 8 squared. All right, or just 25 over 64. About the next one. All right. First, you see the power of 2. Right? And then multiply with minus 1. So for this minus sign or minus 1, all right, it means that you need to flip the term inside right here. All right, flip it over, flip it upside down. So this will give you the negative of 4 over 3 and then square. All right, for this minus sign, it is about the flipping upside down. Okay. And then in the next step, all right, now you can give this power of 2 to everything inside parentheses, including minus 1. Okay. So now you're going to get minus 1 square, 4 square over 3 square. All right, minus 1 square, it means that you have minus 1 times with minus 1. So you're going to get plus sign. And then 4 square you get 16, 3 square you get 9. So that's the answer. Right, so now let's move to this slide. Let's do these examples. Okay, here, even though you see this power outside, right? But here you cannot give this power to everything inside this parentheses. if you do it in that way, it's going to be wrong. Okay, it is because the rule that we have, it is the case when you have x times y to the power n. This will give you x to the power n multiplied with y to the power n. Alright, but we don't have the rule for this one, when you have x plus y, and you take the power n. Alright, if you take it to be x to the power n plus y to the power n, this will be totally wrong. Okay, so here, how can we solve this problem? Okay, let me delete this one. Okay, here you can use the rule of PEMDAS again. Right, P is for parentheses. Right, E is for the exponent, like a term of x squared. M and D is about the multiplying and dividing. AS is about the plus or addition or subtraction. Okay, then if you read from left to right, okay, here you can see that you have the term of parentheses. Okay, so that will be the first thing that you need to do. So you need to calculate the term inside these parentheses for the first step. Okay, so here you need to take it to be minus 2 plus 3, you get 1. And then later on you take square. Okay, so the answer will be just 1. Okay, so here again, never take it to be like this. This is totally wrong. Alright, how about for the next problem? Here again, you just find each term. Alright, minus 2 square, it means that you have 2 repeating terms of minus 2. So actually, this will give you minus 2 multiplied by itself. Right, you have 2 repeating terms of minus 2. Then plus 3 squared. 3 squared is just 9. Minus and minus, you need to get plus. So actually you get 4 plus 9, you get 13. That's the answer. And then for the next problem, all right? Here, you have the power 4, right? So it means that you have 4 repeating terms of minus 3. You have 1 term, 2 terms, 3 terms, and then 4 terms. Okay, then when you multiply minus and minus, you get plus, right? Multiply minus and minus again, you get plus. So the answer needs to be a positive number. Okay, and then you have 1, 2, 3, 4 terms of 3, right? So actually you're going to get 3 to the power 4. All right, and then when you multiply 3 and 3, you get 9. 3 and 3, you get 9 again, right? And then 9 and 9, you get 81. So that's the answer. All right, or you can do it in this way. This is the first method. Here's the second method. All right, you can think about that. Here you have, for the term of minus 3, it is the same as you have minus 1 multiplied with 3. All right, and then you put the power 4. All right, so it means that you can give this power to everything inside these parentheses. Okay, so this will give you minus 1 to the power 4 multiplied with 3 to the power 4. Right, and then the term of minus 1 to the power 4, this number 4 is an even number. All right, so when you take the even power to a negative number, you need to get plus sign or positive value. So you're going to get just 3 to the power 4, and that's it. Okay, And then for the next term, this problem is totally different from the previous one. Okay, when you read the term right here, all right, it means that first you need to take 3 to the power 4, or just calculate what it is, and then later on you just multiply with minus 1. Okay, and we know that 3 to the power 4, you're going to get 81. All right, so in this problem, you're going to get the negative of 81. So that's the answer. Okay, so here you need to understand the difference between this expression and this expression. All right, for the first expression, it means that you take minus 3, put the power 4 outside. Okay, but for the second expression, it means that you take just the number 3, put the power 4, and multiply with minus 1 outside. Okay, so the answer needs to be this negative number, minus 81. Okay, now for the last problem, whenever the power is 0, all right, don't think too much. You just write the answer right away, that it will be equal to 1. So that's it.